Hi everyone, today we're going to be looking at complex fractions. So you might be wondering, what is a complex fraction? Well, these are all examples of complex fractions. Basically, it's a fraction within a fraction. So if we look at each of these, okay, here we have that 3/4, it's inside a fraction. 5/7, it's a fraction inside of a fraction. Here we have another fraction involving variables. And here we have multiple fractions involving variables. Okay. Now, if it consists of just numbers, like our first example here, then we can use our calculator to solve it. So if we're doing this, you have to be careful with parentheses, as usual. Okay. So that numerator has to be in a parenthesis, and the denominator has to be in a parenthesis. So if I go to put this into the calculator, I'll open that parenthesis, 3 plus. Now for the 3/4, you don't have to put that in a parenthesis, but you just have it as a division problem. 3 divided by 4. And we're going to close that parenthesis. Then we'll have our divided by button, because remember, a fraction bar is just another way of dividing. Then we'll have 3 minus 5/7. So 5 divided by 7. And we close that parenthesis. And when we press enter, it is going to give us a decimal, and we don't want a decimal answer. So to change it into a fraction, we'll do our math button. We'll choose 1 for fraction. Oops. And then press enter, and it gives us our fraction here, which in this case is going to be 105 over 64. Okay. Nice thing too about using our calculators for this, it automatically puts it in lowest terms for us. Now, if we don't have a number or a complex fraction completely of numbers, we do have do a little bit of work. And it comes back to that LCD we talked about last week. Now, if we look at this, I could think of this one as being 1 over 1. So in the numerator, this fraction has a denominator of x minus 5. And this fraction also has a denominator of x minus 5. So I need that 1 over 1 to be something over x minus 5. Well, if it's 1, I'm going to multiply it by x minus 5 over x minus 5. X minus 5 is our LCD. Okay. So my numerator, I didn't do anything to it, so that's still 1 over x minus 5. In my denominator, I can rewrite this part here as x minus 5 over x minus 5. And I still have my minus 1 over x minus 5 here. Now in the denominator, so if we're just looking at the denominator, so this portion here, I can write that as a single fraction. So if I do that, okay, so my numerator is still 1 over x minus 5. That hasn't changed. In the denominator, I'd have x minus 5 minus, so I'm using that minus there, the 1 all over x minus 5. Now this portion, this portion right here, I could simplify. Now if I go to simplify that, that's going to be x minus 6. Minus 5 minus 1 is minus 6. And that's all over x minus 5. My numerator is still 1 over x minus 5. Now on closer inspection, you might notice that these are the exact same denominators. So they have that factor in common. So we can go ahead and factor those out. So now all that's left in the numerator is 1. And in the denominator I have x minus 6. That would be my simplified fraction. So I went from this up here to simplifying to this. Okay. Let's try another one. This time we have 4 separate fractions. 2 of them are over w, 2 are over x. So my LCD is going to be wx. Okay. So just like we did last week, whatever's missing, that's what we multiply by. So for that 7 over w, it's missing an x. So I'm going to multiply that by x over x. For the 4 over x, it's missing w. So I'm going to do w over w. In the bottom, 4 over w is missing the x. It's going to multiply by x over x. And the 7 over x is missing w, so I multiply by w over w. So now on our next line, we're just going to write what happens after we multiply that. So x times 7, 7x, and that'll be over wx. 4 times w, 4w, over wx. X over x times 4 over w would be 4x over wx. Then my minus sign. 7 over x times w over w would be 7w over wx. Okay. Now notice all of these denominators are now the same. So I could write this as one fraction over another fraction. So 7x plus 4w over wx. In the bottom I'll have 4x minus 7w over wx. Now the same thing is going to happen here. If we notice, we have the exact same denominator of those fractions. So I can eliminate those. Once I eliminate them, the only thing left in the numerator is 7x plus 4w. And in my denominator, I'll have 4x minus 7w. This would be my final answer. Okay. So there is an assignment on this on MathXL. It's a short assignment, shouldn't take you too long. And I tried to set up the examples on this YouTube video the same order that they appear on your MathXL assignment. If you have questions or comments, feel free to email me or leave me a message on Google Classroom, and I will talk to you later. Bye.